question 3.45 here. So find current I naught, just I in the current. Okay, so we have a interesting one. So let's see, I1, and then let's assign this as I2, I3, and I4. Okay, and we're going to use mesh analysis to solve this problem. That's the method that I'm going to use in this video. So okay, now for doing a mesh analysis, you have to remember when there's two sources, two mesh system that shares one common current source, you combine those two mesh systems and form a super mesh. So I2 and I3 will form one super mesh system, right? Okay, but nonetheless, let's start with I1. We're doing the Kirchhoff voltage law, right, using the mesh analysis method. So start from bottom left corner and we go clockwise, so it would be negative 30V plus 2I1 minus 2I2 plus 3I1 minus 3I4. Okay, and this whole thing gives us 0. I remember, so this equation right here, right? This I1 is going clockwise, right? This, and this. Okay, so from here, I1 is same as I1, right? I is same as I1 because there's nothing conflicting I1. Nothing is impacting it, right? If I1 is like, say, here, then yeah, I2 is affecting it. But it's not. It's just independently existing in the I1 notation, right? Without any other currents affecting it. Therefore, we can draw the conclusion, which becomes our second equation. I'm just going to write it on top of it. I equals I1. Okay? Fantastic. Now, the next thing we are going to do is to, simplify this equation over here. We're finding I, yeah, okay. So negative, so 30V go to here. So 5I1 minus 2I2 minus 3I4. Can't simplify further. This is as far as this goes. All right. So now let's do the I4, right? Mesh 4. It's another independent mesh. So bottom right corner, we turn clockwise. So we have the 3 ohm I4 minus 3 ohm I1. I'm not going to write the ohm next because it's confusing. I3, and then plus 1 I4, right? This whole thing gives us 0. We're still applying the Kirchhoff voltage law, right? Using a mesh analysis. That's literally what it is. A mesh analysis is applying Kirchhoff current law. Okay, within a mesh. Well, within a mesh, there shouldn't be another loop in it. Okay, so let's see. Simplify this. Negative 3 I1, negative 6 I3, 6, 1, 3. So that's 10. So plus 10 I4, right? And this whole thing and give us 0. Okay, fantastic. Now let's deal with the super mesh system. So IS, and then we're still applying Kirchhoff voltage law. Okay, in that case, I super is what? So bottom right corner, so top left corner. So 4I2 plus 8I3 plus 8I3, 6I3 minus 6I4 plus 2I2 minus 2I1. Okay, this whole thing gives us 0. So in that case, we simplify this equation. So negative 2I1. How many I2s are there? 2 of them. So that's 6I2. It's going to be 2 I3s as well. So that's 6 plus 8. That is, let's see, 14. I had a brain freeze. And then minus 6I4. Okay, and this whole thing gives us 0. I think you can simplify this one a little bit. Divided by 2 by both sides, so it's negative I1 plus 3I2 plus 7i3 minus 3i4. 3i4, this whole thing gives us 0. Okay, so right now we have 3 equations, right? The equation 1, equation 2, oh sorry, 4 equations actually, equation 3, and equation 4. Okay, we're solving this one. So here's another conclusion, or relationship that you can draw, is this thing over here, right? We're finding, so we're looking at I1, I2, I3, I4, and I, right? That's 5 unknowns. And we have 4 equations, which tell us it's not enough, right? N x amount of unknowns is equals to x amount of equation, right? That will help you solve the answer. So we're looking for one more, but we applied all the analysis, mesh analysis. Right now we have to use another very powerful tool, which is the Kirchhoff current law, and we apply it at where we see a in super meshes. Mainly we apply it at super meshes and where there is a current source, right? So we're going to apply it this one over here. We call it a not A. So Kirchhoff current law at not A. Okay, so I2. So what is Kirchhoff current law? The amount of current entering equals the amount of current exiting, right? So I2 is doing this clockwise, right? So from here, entering this now before it turns down, it's entering, right? If it's clockwise. So I2 is entering, and 4A is also entering, so they are entering, and then I3 is go up and then leaving the node, right? When it's at A, when it turns right, it's leaving. Therefore, that equals I3. Okay, the entering equals leaving. Now we are done. Okay, and now we have 4 equations, 1, 2, 3, 4, sorry, 5 equations with 5 unknowns. Okay, and it's gonna be a lot of fun. So let's see, we can start simplifying things. Let's see, it's a lot to deal with. It really is. Let's see, so 7, let's see which one should we use. We have I1, and then we have I2. So let's find the common factors. So I1s and I4s are included. Wait, this is 1, 2, 4, 1, 3, 4, 1, 2, 3, 4, and 2 and 3. Okay, so I2, no, I3, no, none of these has common factors. All right, so this is going to be some work. We're going to have to do some work. Let's see, so I2s and I3s, I2s and I3s. Okay, so we can use these equations to simplify I1s and I4s, and then we'll figure out what I1 and I4 is in that case. Okay, or wait, actually, yeah, we can, all right, perfect. So with this equation, so I3, so I2 is I3 minus 4. I3 minus 4, and then I3 is I2 plus 4. Okay, and we're going to apply these 2 equations. These 2 equations. I2 is going to apply the one to the top. So say like here, and then I3 is going to be applied onto this equation over here. Okay, fantastic. Okay, so let's simplify. 5I1 minus 2 times I3 minus 4. Okay, shoot, that's not a good idea. Okay, we're just gonna do this for now. Equals I3s. I don't really know if there's like a logic way of applying, like who's first and who's next. So, okay, I4, and this whole thing is 30V. Okay, so 38V, and then, so 5I1 minus 2I3 minus 3I4. Okay, I guess it's similar to the bottom equation. So let's see. This whole thing gives us 0. All right. So comparing with this equation. All right. So we're not gonna plug that in. Okay. Plus 10I4 equals 0. All right. I guess we can times this equation by 3. And then minus them together to get rid of I3, and then we have I1 and I4 left. Okay. Let's see. So this would be 5I1, no, this would be times 3, so 15I1 minus 6I3 minus 9I4 equals 2, so 1. Okay, and this whole thing gives us negative 3I1, negative 6I3 plus 10I4. This whole thing gives us 0. Minus, so the top equation minus the bottom equation, so 15 minus 3, so that's 18I1, cancels out. Minus, so negative 19I4 give us 144. Okay, so in this case, we can figure it out what I1 is. Right? So we can plug in, no, that's not enough. Can we do I2? No. I1 and I4. All right. I1 and I4. We can do it in terms of, that's still not enough. Oh my gosh. Okay. So maybe we change this into I2s. We have to represent everything into like 1, right? So that's not enough. Then we will move on to this one. So okay, so we can still plug this in, and then and see where it takes us. So negative I1 minus 6 times I2, right? Minus 24 plus 10 I4 equals 0. So 24, negative 3 I1, negative 6 I2, plus 10 I4. Comparing with the equation on top, which is 30, negative 3 I4, negative 2 I2, and then 5 I1. Okay? Oh wait, we already did that. Okay, never mind. Alright. Well, we can apply this I2 in here and then get rid of something. Let's see. So we can apply I2 in here. Alright. So this would become, let's see. Zoom out a little bit. This would becomes negative I1 plus 3I2. What is I2? That's 3I3 minus 12 plus 7I3 minus 3I4. That's give us 0. So 12I1, negative I1, plus 3I3 plus 10I3 and minus 3I4. Okay? Yes. let's see. So here is a equation that we can use that we obtained earlier, right? So it's negative 3i1 minus 6i3 plus 10i4 gives us 0. Okay, so I time this by 3, right? So it would be negative 3i1 plus 30i3 minus 9i4 plus 36 minus this equation on the bottom, i4, right? Why don't I? Okay, sorry. Never mind. Actually, what I should do is this. So instead of times by 3, I should get rid of I3, and then here's I1 and I4, and I can use these two equations to solve one of them. Right? Okay, so what I should do is find the common factor of 6 and 10. Okay, so in that case, I will time, let's see, 3. Alright, this times 3, and this times 5. Okay, so negative 3i1 plus 30i3 minus 9i4 equals 36, and this is 5. So negative 15i1 minus, what is this, 30i3 plus 50i4, this whole thing gives 0. Okay, so top plus bottom, 36. So negative 18i1, this cancels out, and then plus, so that's plus 41i4. Okay, all right, and then here 81i1, perfect, equals 144. We add these by both sides, which is 1 and then 50, right? And then this is 1, this cancels out, 1 minus what? 41 minus 19, that gives us 8. No, that gives us 2, 3. No, 22, right? So I give us 22. Wait, let's see. Plug into my calculator. What's 150 divided by 22? Let's see, 150 divided by 22 gives us a number. Okay. But I think there's a mistake somewhere. Alright, so I think I found the mistakes. It's plus 8 over here instead of negative 8. So this becomes 30. 30 minus 8 is 22, 66. And change all the way here. Instead of 114 is 66, right? This plus this is 2. So 102. Alright, and then I4, so I4 is 4.636. Okay, and then I1 is is 66 times 19 times I4, which is 19 times this number, right? So times 18. Okay, so 19 times the answer times I4 plus 66 and divided by 18, and I1 gives us 8.5606, right? Repeats forever, or sorry, repeats forever, these two, or 8.561 ampere. Okay, and since I equals I1, therefore I is 8.561 ampere. And this is how you solve this equation, this problem. It was right. It was a journey to figure this one out. So I would definitely suggest you to use your calculator and or use the matrices method, because as you can tell, this one sometimes you can get lost. Like, you have to have a very strong vision of where you want to solve next, and then combine which term together to simplify which term. So yeah, I need practice on this as well, because usually I just use the calculator. So yeah, hopefully this was not too confusing, and you were able to follow through in the end. As you can tell, one sign mistake could make a huge mistake in the end. But yeah, hopefully this was helpful. Good luck on your studies, and I'll see you in my future videos. Bye.